Okay, so let me quickly review what we saw in the previous introductory tutorial on VLANs and move on further. So let me click on the switch 2960. So let me zoom it a little bit more, and we'll use about 4 PCs. So last time we ended up putting 2 of them in one VLAN and the other 2 in the second VLAN, right? And I said even though they have the same 10.0 prefix, once we put them in 2 different VLANs, they cannot communicate with each other, right? So being in the same network prefix is not the only requirement. They have to be on the same VLAN, right? So let me just to see things more easily or clearly, we'll put them in different VLANs, different network prefix itself, in addition to putting them into different VLANs. So let me label this as 10.10 and label this as 10.11. And label these as 20.10. So now they are in a different prefix. Right. So now let me connect them using cables. So we'll connect a computer to a switch using a straight through cable. Okay, so we'll leave the first 2 for future use. We'll use 0/3, then again connect this to this 0/4, then connect this to this 5, connect this to this, okay, 6. So let me go ahead and give the static IP address for these computers. So 192.168.10.10. So 192.168.10.11. Once you press the tab key, the subnet mask comes automatically, and you have to just check if that is what the subnet mask you want. Otherwise you could change it. Most of the time we don't need to change the subnet mask that shows up. So this is 20.11. Alright. Okay, so they are in still one VLAN, right? Because as I said, by default all the fast Ethernet interfaces are put in one VLAN. So if you click on VLAN database, only one VLAN shows up. This is the default VLAN number 1, and all of this 0/3, 4, 5, 6, everything are in one VLAN. So let's go ahead and create our second VLAN. It could be any number, need not be just number 2. Just use 2. So add it. Then we'll put 0 and 3 in one VLAN. That is the default VLAN number 1. That's this 2 interfaces, basically the 10.0 prefix in VLAN 1 and the 20.0 prefix VLAN interfaces 5 and 6, the second VLAN. So how do we do that? We leave 0/3 and 4 as it is. Let's go to 5 and put it to the second VLAN. 6, put it in the second VLAN. Okay, and we close it, so that it will take a while to configure. And so you can ping from 10.10 to 10.11. You should be able to do that because they are the same VLAN, and you should be able to do it, same network prefix. But not from 10.10 to say 20.10 or 20.11. You cannot do it because they're in different VLANs. So that's where we need a router now to communicate across VLANs. Okay. So we need to put that router as a member of both these VLANs, right? It has to be a member of this 10.0 prefix, basically VLAN 1, as well as a member of this VLAN 2. So when we click on the router, let's go to generic router, we need basically two cables. One cable connecting the router to an interface that is part of VLAN 2, and another cable that connects the router to a switch that is part of VLAN 1. So let's do that. So connect this. We need a straight through cable to connect a switch to a router. So let's first configure, say we'll pick 0/2 and 1/0 we'll use for this 20.0 prefix of VLAN 2. So let me label it for clarity. So always routers typically get the first available address on a network address space. So I'll put 20.1. So we need to configure that. So how do we do that? Enter no, press and return. So now we need to get into the privileged execution mode or the root mode to configure anything. So we do that by entering enable. So it should get this hash sign, and at this prompt we can see any settings that we have made. But if you want to change or do any configuration, we have to get into the configuration mode. So we want to configure the terminal, so press configure and enter configure space T to configure the terminal. Then we want to configure that particular interface which we just selected, which was what, fast interface 1/0. That's what it is, right? So how to get into that? Type int tab will get you interface, fa tab will get you fast Ethernet. You could put a blank space in between this or no blank space, either way is fine. So 1/0. So that's this interface, and now we want to set that IP address. IP address this 192.168.20.1, and the subnet mask, which is this .0. Now you see it is still red in color because we have not turned it on. So we have to say no shutdown to turn on that interface. Press and return, enter. So you can exit out of this interface, right? So they will communicate to learn about each other. So let me meanwhile add a second interface from this. So now 0/1 connecting to 0/0. So let me label this as 192.168.10.1 prefix. By the way, this, if you click on this, we want this 20.1 which we added on from the switch point of view. If we look at the switch where we added this, the green one, that is a 0/2 interface, right, for the 20.0 prefix. So by default that is on VLAN 1, but we want it to be part of VLAN 2, right? And the one that we just added, the 0/1 in the bottom, it is supposed to be in VLAN 1 communicating with the VLAN 1 10.0 prefix. Okay, so make sure you make that change. Alright, so now let's configure this interface. So let's go to interface fast Ethernet 0/0, the one we just added, and we want to configure it the IP address 192.168.10.1. Alright, and turn on that interface, no shutdown. Now let me come out of this. Now if I say show IP route on this basic command prompt for the execution mode, you can see the routing table. So show IP route shows you the routing table. You can see that the 10.0 prefix is connected to the 0/0, this bottom interface, and the 20.0 prefix is connected to the 1.0, the top interface. So now let's see, is that sufficient? So let me try to ping from 10.10 to 20.10. Let's see what's going on. It will not, because I have to do some more settings. Let me stop it, it won't work. But let me try to ping to 10.11 from 10.10. They are in the same network prefix and they are in the same VLAN. So you should be able to ping. So that means if you're in the same VLAN, same network prefix, you don't need to go to the router. There's a switch to be able to forward you to the destination machine. But when you're in a different VLAN, we have to go through a router. So if a machine doesn't know, if the destination machine for 10.10, if you want to communicate with 10.11, 10.11 is a destination machine. So the source machine 10.10 does an ARP, as you saw in the previous video, finds out the MAC address of the ultimate destination and uses that as the next hop itself to send a packet to that destination. But if the destination is not in the same network, like if you want to ping to 20.11 from here, then 10.10 has to send it to a gateway router which can route it further, right, if the destination is not in the same network. So what we have to do for that is we have to configure the gateway router, the default gateway router for this 10.10 machine. So for that we have this 10.1, that's the default IP address of the gateway router for this interface. So we have to set it. Alright, we don't need to set the DNS server for this. Okay, we are not doing any web-based communication. So this should be done. Now let us see whether this works. Right, let's see what happens. So I'm doing a ping to 20.10. It will not still work. The reason for this is I have configured the gateway router for this machine, right? So let me run this in the simulation mode to see where are the messages going. So we could turn on the simulation mode. We click on this, edit filters, show all none. I just want to see the ICMP messages. Let me start auto capture, but let me run the command. So you can see the echo request will go to the router, right, and the router sends an ARP request to this, and this guy, the message gets stuck up there, right? You saw this failure symbol here. The echo request reaches the router forwards it back to this, and the switch sends it to 20.10, but you see here this guy doesn't know how to respond back. Alright, so the reason for that is because this PC is not configured with its own default gateway, because it wants to respond back to 10.10, which is in a different network. And this PC doesn't know what is the default gateway to reach a machine that is not in the same network, because 10.10 is not in the same VLAN as 20.10. So it needs to know what is its default gateway. So what we have to do is, let me stop this and let me go back to the real-time mode. Let me open this PC and do an IP configuration. I need to set its default gateway address to 20.1. Similarly, for this I need to set its default gateway address to 20.1. I don't know why it was DHCP. We will come to DHCP in another video. This is 20.11 and then this is its gateway address. Let me configure for this guy. Its gateway address is 10.1, right? Alright, so now let's try to ping. You see it is now able to get back the reply, because now the other guy 20.10 knows that it has to send to 20.1 its gateway router, and when the message comes to 20.1 it knows that the destination 10.10 is on this VLAN, so it can send it out on this interface. Okay, so we can try to ping to 20.11 and it'll take a while to figure out its MAC address. So the first one may time out, but second one will work, right? So now we run it again, we'll get it, because there may be a timeout to do the ARP request response. Okay, so you can even run it in the simulation mode to see how it looks like. We turn on the simulation mode. Auto. I want to send from, say, let's try 10.11 to 20.11. And is it starting? It started. Okay. Alright. So it now goes to the router. And then it goes to that guy. So switch, and then it should go to, this is an ARP request because it's trying to find out the MAC address. So 20.11 responds back with its MAC address, sends back to the router. The router sends back now to 10.11 the ARP response, and so now it sends a second ICMP request. Let me run this. Alright. Okay, so let's stop this. Okay, so if you want to simply see it in the command prompt, ping, you want to ping from 10.11 to 20.11. Is it still in this mode? Get into this. Right, we'll get back the reply. Alright. So make sure you turn on to real-time mode to see the immediate response, otherwise it will go through the simulation mode. Okay. I think we can stop with this. We'll come back in one more tutorial and see how we can do DHCP on a VLAN. Okay.